In this lesson, we'll look at listeners and toasts. We'll use a sample app shown here that I've called Classic 8-Ball. It's a takeoff on the Magic 8-Ball game of questions and answers. Let's first give it a try and see how it works. I'll enter a question here. Will it rain today? And click Get Answer. And we see the display below of what's termed toast. And the toasts don't appear for very long. I can click it again and get a different answer. As you can see, I've set up Eclipse with the listener toast app files showing side by side with the emulator. It's a convenient way to demonstrate and debug code. So let's take a look at the code for the app. Now we're getting into examples that involve a bit too much code for you to add in yourself during a lesson. So all the code needed is included in the app in the working files sample workspace. I suggest what you do is watch this lesson and then, if you like, go back and open the app yourself in Eclipse. Let's first look at the XML code for some of the app resources, starting with the strings XML. Now I've opened a number of our files in the center window, so let's expand that. And we're starting with strings, so we'll open that file. We see that we've defined strings for the app name, the Get Answer button, the hint for entering a question, and the header displaying the title Classic 8-Ball. Now let's look at the dimensions. Here we see we've defined density independent pixels, or DIPs, dimensions for the header, the question text, the header height, and button size. And in styles, we've defined our layout themes. Now let's move on to the main XML. We're going to look in detail at the user interface in coming lessons, so for now we'll just go over the basics for our app quickly. We're using a linear layout in which the fields are defined in a sequential manner. This is a common type of layout and allows the content of the display to be resized for various screen sizes, as indicated by the fill parent attributes shown here. And it's using vertical sequencing of the fields. This first view provides a spacing of 30 DIP between the top of the display and our header, which is in the next field. The wrap content parameter indicates that the field dimensions should enclose the content. In this case, there isn't any content, so the width is 0. The header is in a text view tag that displays the classic 8-ball text we see here. The dimensions for height and text size are defined in the dimensions XML file. The width wraps the content and it's centered, as shown here. The edit text tag defines the field holding the question from the user, as we have here. An edit text field captures user input and makes it available for manipulation by the app Java code using the ID defined here, or in our case, question. What you see happening in the display as we enter text, such as changing today to tomorrow, is all done by the Android system. It automatically captures the text. The width is defined as wrapping the content. So if we enter more text, for example, just some dots, you see the width increasing. And the height also wraps the content. The field is centered horizontally. The hint text is defined by the string we looked at in the strings XML file, and the size is determined by the dimension we looked at in the dimensions XML file. This next tag, this next view field, is another spacing field of 10 DIP. And this last tag is for the button. The ID defines a name, Get Answer button, that will let us set a click listener for it in our Java code. The width and height wrap the text label. It's centered, and the size of the text is defined in the dimensions file. So now let's move on to the Java code. At the beginning of the Java code, we see some familiar elements from previous lessons. The package name, imports, the class extending activity, the onCreate method, override and setting the content of the display with a reference to our main XML file. Notice up in the imports the inclusion of the onClick listener, button, and toast classes that we'll be using in our code. Now let's look at the sequence of statements that sets up the click listener for our getAnswer button. It's in these 4 lines here, and let's look at them in detail in a graphic. I realize that this graphic is pretty busy. I've done it this way because I think it's useful to see all the pieces of the puzzle in one page so you can see the relationships between all the elements. A listener is code that's executed when a particular action takes place. In this case, a button click. So let's tear it down piece by piece. First, look at the commented code groups. The first is code to declare a button variable corresponding to the getAnswer button on the display screen. Now let's skip down to the 3rd and 4th statements. They define an onClick listener object containing callback code that will be executed when it's invoked. The middle statement links the getAnswer button with the getAnswer listener object. This sequence of statements is a very common grouping, and you'll use these many, many times in your app code. So let's go back up to the first statement and look at the details. Button declares getAnswer as a button object. It then sets that object equal to the button on our display. It uses the findViewById method to locate the ID of the getAnswer button in our XML layout file. It then uses casting with the object type in parentheses to declare the type of object returned by the findViewById as a button. Casting prevents a compile time error due to object type differences when we assign one to the other. We're essentially promising the compiler that the objects will be consistent. In the next statement, we use the setOnClickListener method of the button class to set getAnswerListener as a listener associated with the getAnswer button. In the next statement, we declare getAnswerListener as an onClickListener object type and then assign it to the new onClickListener object with the callback code that will be invoked when the button is clicked. The first statement of the callback code is the onClick method with the view v as a parameter specifying the view that's been clicked. In the body of the onClick method is the code that will be executed to respond to the click and display the toast with the answer. And now let's look at the code that will generate the answer. First, we create a random number generator object, toastGen. We then use the nextInt method to generate a random number between 0 and 19 and assign it to the variable toastNum. Now, we're relying on the computer gods to generate the right number for our answer. We increment toastNum by 1 so that we have a number between 1 and 20, which we'll need for the switch function below. We create a text variable to hold our answer and then use the switch to retrieve a string from our strings XML file. And now we move on to toasting our answer in this sequence of 4 statements. And let's look at each of these in detail. A toast is a display on top of the application display created by the setContentView method. A toast message appears for only relatively brief periods of time. And there are 2 options, a short length and a long length, as we're using in our app. So let's look at these statements in detail. The first statement declares and names a context object and then assigns the context for the application to it using the getApplicationContext method. The second statement creates a variable for the duration of the toast and assigns it the long length constant from the toast class. In the third statement, a toast object is declared and assigned the value produced by the makeText method of the toast class. MakeText uses 3 parameters: the context, the duration, and the text itself. And finally, the fourth statement displays the toast using the show method of the toast class. Finally, let's review the sequence of what happened in using our app. We set up our starter display. The system accepted input from the user. We set up a listener for button clicks. We responded to the click by generating an answer that was used in a toast to display it to the user.